First of all, thank you for coming. Always the same. Huh? Nicola asked me to talk about a bit about zoning in wildlife. It's a topic that is a bit difficult to approach because there is almost nothing. So I just took my ideas regarding two diseases or three diseases that I follow in my life, and you will see, easy to understand. Which wildlife diseases, first of all, and for what reason we are trying to make a zone for these diseases. Historically, they have been considered mainly when wildlife diseases affect trade. I mean, trade is the hardcore of our system. It's not public health, it's not conservation, it's trade. And this is the first limitation. We are always talking about trade. And even the new animal health law of the EU has changed something. Before we had infected area for rabies, now is a choice of the country. So even if a disease like rabies can be managed without any zoning. And this is a bit a problem because it closes a bit the door for doing a lot of things. The aim of zoning in wildlife are always two, to define the boundaries of infected areas where prevention measure, like biosecurity mainly, should be increased in domestic animal. And the classical example is avian flu. We are not trying to manage avian flu in itself in wild birds, but we are trying to manage to increase the biosecurity level where wildlife, wildfowl will bring avian flu. So the second aim is to define the boundaries of an area infected by a pathogen of interest, like African swine fever and wild boar. We are just understanding where the disease is, to eradicate or to control the disease in the infected species. Could be even rabies in foxes, but for African swine fever and wild boar, it's compulsory at the EU level, for rabies, not. Okay, so zoning. How can we define zoning in wildlife? This is just something that in my mind is not written everywhere, nowhere. Aim. Which kind of host? The pathogen, the landscape, and this is a GIS part, and the surveillance. All these components allow a good zoning for the management of the disease or for the increasing biosecurity of the domestic animal living in the zone that is considered at risk. Very easily, pathogen, if it is a micro or macro parasite, which are the susceptible species, which mode of transmission, which environmental resistance, so this is quite important, which morbidity, which lethality. And I would really suggest to take in consideration R0, not because it's my hobby, it's 40 years that I'm estimating R0 for diseases, but because R0 is an important measure that is not recognized at any level at in the international organization. Remember, the landscape, biotic and abiotic features, type of ecological habitats, fragmentation, anthropization, all the same, huh? You know better than me, it's your job. Then host species, number of species representing the epidemiological reservoir of the infection. Think about avian flu. How many species are involved? How many species maintain the virus? And so on and so on. Use of space, if they are terrestrial species like a wild boar, or birds like a bat for rabies. Is not a bird, sorry, flying animals, sorry. Anyway, you understand what I'm trying to say. Individual home range and overlap between the home ranges, which density, which demography, that is quite important. I mean the turnover and the reproductive capacity of the species, that is the epidemiological reservoir, the seasonal movement or migrations in case of birds, and continuity of distribution range. All these aspects should be included in the performing the zoning. Not so easy, you need a lot of data. Anyway, this is the most important. And for us, normal veterinarians, not scientists, we are many normal veterinarians here, the surveillance strategy is the most important point, because zoning is based on the distribution, spatial distribution of the disease. So we have, when we are talking about surveillance, we need to understand the capacity of the surveillance system to properly detect the infection. We can call this capacity as sensitivity, that if we want to summarize it, the sensitivity tells us how many cases we lose before to detect the case. If the sensitivity is 10%, it means that we are losing 90% of the cases. In wildlife, if we have 10% of sensitivity, we are very, very happy. And this is a crucial, critical point for zoning. We are not interested in specificity because if we have false alarm, it's not a problem. The problem is that we don't know where the disease is. This is our problem. Let me see what I wrote because I cannot remember everything. So, okay. The sensitivity. Oh, try to follow me here because even I am lost here. So I ask your help. The sensitivity of the surveillance system is defined by 3 steps. And the ability of the system to detect the suspect case. When we are building a surveillance system for wildlife, we are not looking for the disease. We are looking for the suspect cases. That is completely different. We are looking, for example, for dead animals. Does not mean that each dead animal is sick of the disease we are interested on. So the first step is how many dead animals we found. And then we have to estimate the relative risk of each category of suspect cases, for example, through active or passive surveillance, car accident in respect to hunted or culled animal, and so on and so on. And then, finally, we can calculate the sensitivity of the system. It seems quite complicated, and it is more complicated than you can imagine. It's really a problem to have a good assessment of the surveillance system in wildlife. But this is the way and should be standardized this way. Instead, all the countries are trying to manage as they can. And this would be a very important point to be stabilized, let's say, I don't know how to say in English, anyway, at the international level. I mean, I was talking with Nicola before. At the international level, there is a huge effort to have the same diagnostic system. There is the same effort to have the same surveillance system capacity. So we are really unbalanced from the laboratory point of view. Any disease can be diagnosed in few hours in Europe. I'm mainly talking about EU because I belong to the EU. And there is no country that is not able to diagnose avian flu or African swine fever. But we don't have any standardized surveillance system. This should be the next step. Anyway, so we have 2 main scenarios. One scenario is when we are familiar with the characteristic of the causative agent, the host population, and mainly we know the epidemiology of the current epidemic. We know what we are talking about. We know how many hosts, we know the prevalence in the host, we know the distribution of the host, and so on and so on. The other scenario is the opposite. We do not know the essence of the epidemic. We know that we are under an epidemic, but we don't know exactly what we are doing, what we are facing. We know that there are problems. And this is quite typical in wildlife. So what can be done in the first scenario, when we know something? We could apply the metapopulation approach. The metapopulation was invented by Ansky some years ago. He's a Nordic scientist, a genetist, that said simply that there are some metapopulation that are genetically distinguishable from other, despite they are the same species. So the group of veterinarians can be genetically similar among them and different from the group of botanics. Something like. So the veterinarians is a metapopulation in respect to the botanic, despite they live in the Padua University, all of them. Can you follow me? Quite easy. What does it mean? That the veterinarians live in homogeneous mixing, we mate among them, and the botanic mate among them. And this is important because we can understand that there is a population, or a part of a population, that are living together and are spatially separated from other metapopulation. Within the same metapopulation, each individual has the same probability of contracting the virus, the infection, during a defined time unit. An individual living in a neighboring metapopulation has much lower probability of contracting the infection in the defined time unit. This concept of metapopulation introduced three concepts: population, size, density, blah, 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 spatially separated, a specific identifiable geographic location, and unit of time. How long do we need to identify this metapopulation? 1 day, 1 year, 5 years, and this will change the size of the metapopulation. And this is an example of geographical evolution, for example, of African swine fever in Italy. And we have three different approaches in English, probably. The one based on the minimum convex polygon, you see the increasing of the area. This is based on municipality, that probably is the most strong in absolute. And the one on landscape. Here you see, probably you don't see anything, but I'm sorry, we should be in the dark. This concept of metapopulation in epidemiology can be simply translated into what is defined as the critical community size. How many animals of a certain species are needed to maintain the infection for a certain period of time. And for this critical community size, we have already some formula that can be used. I did just yesterday or 2 days ago for the wild boar and African swine fever, just to show you, and then few quick calculations, and we start to have an idea of the population size need to maintain the pathogen. We need accurate number and, above all, the speed at which the infection spreads. So we need to estimate several parameters, in particular this bloody R0 and this alpha. Then, for example, in wild boar, we need 270 wild boar to maintain the virus for 1 year. And these 270 wild boar are the critical community size to maintain the infection for 1 year in our mountains. We will have a risk area corresponding to the area where one or more critical community size of the infected species live in continuity. And thus, the zoning will correspond to the area where I intended to carry out epidemic the management of, or prevention against other susceptible species. Maybe I can give you a better example. This is what I did before, and this is a possible different. We have different, I don't know if you see, we have 1, 2, 3 different critical community size, metapopulations, that has to be managed in 3 different ways. And for each one of these metapopulation of critical community size, the virus can spread to other critical community population according to the geographical characteristic of the landscape. Here, just for example, here is more easy. Here it is almost impossible, very difficult. Here is more difficult than here. This can be estimated. There is also the photo of Giorgio with the, but okay, you don't see here. The problem is that, for example, in an area like Bologna and Parma, you have very huge critical suitable areas that contains a lot of small critical community size. So you have to manage a lot of small population, a lot of small wild boar population. But at least you know what you are doing. And you can say, I don't want the virus pass this line. So you can try to manage. And this is very difficult, but you can imagine a system, and I will show you here what has been done in Belgium. And Italy tried to, you know, we are almost all Italian, we tried to do the same as Belgium. With the same person that I was the one, but they did and we didn't. So, and then we go to another disease that is most interesting, especially here in Padua. Paolo Molatti is laughing. This is HPI in wildlife. Think about that. I'm very, very practical. In the Po Valley, this for our foreign colleague, this is the Po Valley, this is the Po River. We have 1 million, at least, of waterfowl susceptible to avian flu. During the winter 24, we had 51 cases reported. 51 cases out of 1 million of birds. What does it mean? Is it possible that 51 cases represent the epidemiological evolution of avian flu in a population of 1 million? It means simply that the sensitivity of our surveillance system is something just around 0.01. If I have to set, my zoning according to this kind of finding, well, I'm wasting my time and my money. So, and this is an idea that we had together, Giorgio, and many, many years ago, is just to better say, okay, we have the water bodies, we have the sense of the animal, we have, the flying distance of the ducks, according to percentile, something like, they were ringed duck. And so we know that 50% fly in 50 kilometers, blah, 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 blah. And so you can draw, you can just iris map where you have your birds interested in the spreading of avian flu. You don't need to go to sample, because whatever you do is not enough to understand where you have the disease exactly. So it's better to imagine where you can have the disease. And in this case, the goal of the system is not to fight avian flu in wild birds. That is technically impossible. But it is to increase the biosecurity level in the farmer in order to prevent the introduction of avian flu. So these are the farms where you have to increase the biosecurity level. That's finished. But also for this, you need a good system. You need to to have the shapefile of the water bodies, the number of birds, the species, blah, 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 blah. That's all. It's not a codified activity. The zoning will result from AIM, available data, technical capabilities of the services, validation through consistency and technical scientific approach. That's all. Thanks for the attention.
Any question?
Thank you, Vittorio. Have you considered maybe techniques like niche modeling that can also describe the habitat suitability? I've seen that working in other areas where you can not only for the current distribution of the wildlife, but also forecasting the future in climate change situation right now. So,
absolutely. Thank you. The question is, I couldn't, otherwise would be one day of yes, absolutely is one of the critical points, because now even if you are not sure that the disease is there, but the disease will move, and will move according to the habitat. So it's very, very important to know which is the preferred habitat for the movement of the disease. It's not so easy. The main problem, from the technical point of view, if I can, is that this bloody society is using, come si chiama? Quella, citizen science.
Ah, citizen science.
Okay. Mm-hmm. Citizen science is not a science. It tells you where the people goes, not where the animal. If you look, the data from citizen science regarding the distribution of wild boar is completely different from the distribution you obtain from radio-colored wild boar. Why? Because the citizen science is based on visual, on seeing the wild boar and reporting to you that you are the scientist. I have seen a wild boar there. But this does not mean that the wild boar is always there or it goes there most of the time. It means that you, the people, are going there. And the same is for surveillance. Most of our surveillance is based by opportunistic reporting by people walking, by people going with the dog, by people going to fish and so on. So it does not reflect where the animal dies, but it reflects where the person goes. So we need to have accurate data amended without this bias of the people. And the only way is to radio-color wild boar, radio-color birds. It's incredible. When you radio-color a duck, you see that it does a completely different life in respect what is expected by you. Yes, but this is the next step. And for this, GIS is of paramount importance. We already contacted them because of the way to find which are the preferred habitat for the disease to spread, because it's quite important. You set better your surveillance, you set better your, okay, sorry, too long. I could speak about hours.
Another question from me. Other question, sorry. A question.
Nicola, dagli il microfono.
Sometimes we don't have data about diseases in wildlife.
Yeah.
And we use as a proxy, let's say, human data.
Yeah?
So that's even more complicated because often data from human cases are aggregated. We can not know where the person exactly got infected. Public health agencies, they share just data per municipality or NUTS level 3 in the best case scenario. So I'm currently working on a data set like that. It's tularemia in Europe. We know that it's a disease that it's mainly based on exposition of hunters, mainly hunters, or people practicing aquatic sports. So how do we identify a local scale, this ecological niche, places where humans get exposed when we just have aggregated data at communal level?
If you start, aggregated data should be forbidden by legislation because they are Okay, you can show aggregated data, but you must have, you need the availability of the database, not, you know, in Italy we have this aggregated data by province. The province is thousands of square kilometers, so you don't need, if you have only this source of data, you cannot manage, according to my idea. But you can do something different. In your area, you can really identify the habitat of a species, and they can help you, because it's enough to have few good data about a species like rabbit, brown hare, whatever, for tularemia, and then after, you can have an idea where the disease is because of the host. But then after, you have to follow the human side in a different way. And then for tularemia, you have a huge problem of the import of animals. I don't know in France, but in Italy we import a lot of brown hare from infected countries, and this is one of the system to spread the disease. So you should have also this kind of data. It's quite complicated, but aggregate data should be forbidden by legislation.
No. Wait a moment. Before break. Sensitivity of the system. Nice concept.
It's not sensitivity of the test, eh?
No. The system.
Of the system.
Yeah.
Okay.
Never heard before.
I know. I'm here.
Where we can find some resources?
The best, you have two sources. Cameron surveillance.
Angus.
Yes. FAO manual, I don't remember which number, and applied on the field, Vittorio, Guberti, FAO manual on African swine fever, second edition. Now, the first one I take was judged by the 25 referees. You must be one of them, huh? One of this body. Can you imagine 21 referees? One says too long, the other one is too short. In the second version, I also show you the system, how to estimate, if I remember correctly. In the BTSF was always presented. The sensitivity was an exercise of the BTSF in Cardiff, for example. So there are room for improvement, but there is also room for understanding.